Hello, in this example, we're being asked to determine whether the following functions are even, odd, or neither by using the test that we learned of how to figure these out. And the test is actually fairly easy. It's one of substitution and then elimination. We have to go through and first of all test to see whether or not the functions we're after are even or odd or neither by making a really brief substitution right here. And the substitution goes like this. The substitution that we're going to use says that in order to test this, if we have a function like f of x, to test, replace x with negative x in the function and see what the result is. So in our first case right here, we're going to substitute in negative x everywhere we see x into the function. So let's see. If we do that, that means we're going to take negative x raised to the 2/3 power minus 1. Now how do we figure out what happens with this 2/3 power? Well, remember what that 2/3 power means. It means that we'd be taking the cube root of whatever we have right here and it's raised to the power 2. And that's a useful way of looking at this because anytime we take a negative number and square it, it's exactly the same as if we took the original number squared without the negative sign right there. And so really this function is equal to x to the 2/3 minus 1. Since this is exactly equal to the original function we started out with, we say this is an even function, which means that it's going to be symmetric about the y-axis if we were to graph it. We carry out the same test right here for part B. Well, to test, again, we're going to replace x with negative x, and it's going to be the same for every single time we run this test. We always substitute in a negative x in place of positive x. So we're going to take negative x squared plus 3 inside the parentheses. So in this case, if we make the substitutions, this is going to be negative x times, let's see, negative x squared is the same thing as positive x squared plus 3. Now we'll note that this is not exactly equal to the original function, so we know it's not even. We can eliminate that possibility. Is it odd? Well, to find out if it's odd, we take a look at what would happen if we put in the negative of f of x. Well, the negative of the original function is the negative of x times x squared plus 3, so we're going to conclude that since this is true, it is equal to the opposite of the original function, then we're going to conclude that this is an odd function. Alright, let's try this third one. If h of x equals the absolute value of x over x cubed minus x, what happens with that? Well, this one looks a little bit more complex, but really the idea is still exactly the same. We're going to substitute in a negative x in place of x and just see what happens. So we take the absolute value of negative x in the numerator, and in the denominator we take the negative of x to the 3rd power minus negative x. Well, a little bit of fancy math here tells us that the absolute value of negative x is the same thing as the absolute value of original x. It doesn't matter what sign we put inside those absolute value brackets, the result is always positive. And in the denominator we take the negative of x, the cube of negative x, and that is exactly the same as the negative of the cube of x. So negative x cubed, that's like negative x times negative x times negative x, the result is negative. We're subtracting negative x, which means that we're adding x down here. Well, certainly this is not equal to the original function f of x, so we're going to conclude that it's definitely not even. Figure out if it's odd, maybe we need to do a little bit more work right here. From the numerator, well, there's nothing much we can do, but in the denominator you'll note that we can factor out a negative 1 from both terms, and we're left with the following expression. And this expression is exactly the same as the negative of the absolute value of x as a fraction divided by x cubed minus x. And that is the negative of the original function. And so we conclude that we have yet another odd function. That's the answers that we wanted right here, and so we're done.